Okay, ladies and gentlemen, this is your well-rounded math teacher, Mr. Picard, and we're going to be solving radical equations and inequalities today. Let's just jump right into it. Okay, so if I had basically just the square root of x equals 10, the opposite of squaring something is the square root. So the opposite of square root is to square it. When you square that square root, it cancels it out. So I would just get x equals 100, okay? So that's kind of what we're getting into. Get that square root by itself, okay, right here. Isolate the square root by subtracting 2 to both sides, x plus 1, and that equals 2, and then square both sides. So I'm going to square this side, and I get the square cancels out the square root, and I get x plus 1 equals 2 squared is 4. Subtracting 1, x equals 3. And there we go. You might want to plug it in and check to make sure it works. 3 plus 1 is 4. Square root of 4 is 2. 2 plus 2 is equals 4, so it does work. Sometimes you get extraneous solutions where you actually get an answer, but it doesn't work when you plug it back in. We're going to skip to, I don't even want to get into that. I don't even think that one works out, to be honest. So let's go right into this. Number 3, solving the square root. Get the square root by itself, isolate it. So I'd add 1 to both sides. Square root of x minus 2 equals 6. And then square both sides. To get rid of the square root, square cancels out the square root. I get x minus 2 equals 36. Add 2 to both sides, x equals 38, and that's your answer. If you plug that back in, you get the square root of 38 minus 2 minus 1 equals 5. Well, 38 minus 2 is 36. Square root of 36 is 6. 6 minus 1 is equal to 5, so that does work. Okay, 1/3, if I just had x to the 1/3 power, that's the same as the cube root of x. So I'm going to leave it as 1/3. I'll show you how we take care of that in a minute. But yeah, this is kind of the same thing. So isolate, this is your radical term. That's a cube root of 5n minus 1. So I'm going to add 2 to both sides, and I get 3 times 5n minus 1 to the 1/3 power. I'm going to set that equal to 2. Divide both sides by 3. I'll leave that as 2/3. That's fine. 5n minus 1 to the 1/3 equals 2/3. Okay, so what I got to get that to be 1. I want to get rid of the 1/3. So I'm going to multiply it by 3 because 3 times 1/3 is 1. So I'll make that. Take that to the 3rd power also. That's no different than the cube root of 5n minus 1. Well, to get rid of a cube root, you would cube it. That's an inverse operation, so kind of the same thing anyway. Okay, so the 3 cancels out the 1/3 because that's 1/3 times 3 is 1. So that's 5n minus 1 equals, well, 2 cubed is 4, and 3 cubed, oh wait. Okay, I screwed that up. Let's just write it down. 2 to the 3rd over 3 to the 3rd. Doing this, I'm going to get 5n minus 1. That's equal to 8. 2 cubed is 8 over 27. You could put a decimal for this if you wanted to. That would be fine. Okay. So I guess I would subtract 1 from, add 1 to both sides. So I'm going to add 1, but that's 27 over 27. That's 1 equal to 1. So that's what I'm getting. 5n equals, that's 35 over 27. Divide by 5, or I could multiply by 1/5. I think I'm going to do that because I have a fraction over here. That's 5 over 1. They cancel out, and equals 5 goes into 5 once. It goes into 35 7 times. So I end up with 7 over 27 as my answer. Okay, All right. To the 1/4 power, that's like the fourth root. I still got to add 2 to both sides. 2y plus 6 to the 1/4 equals 2. To get rid of that, I'd take it to the 4th power. Okay? 1/4 times 1 is 1, so I get 2y plus 6 equals 2 to the 4th, if you plug it into your calculator, is 16. And then finish solving it. Once we get out of that radical, or the rational exponent, 2y equals 16 minus 6 is 10. Divide by 2, y equals 5. Okay. One more here. Ooh, cube root. I'm going to subtract 5. I'm going to get a negative 5 now. So 3y plus 1. Now that's the same thing as the cube root of 3y plus 1. You could write it like that if you want, or you could leave it to the 1/3 power. It doesn't matter because you're still going to take both sides to the 3rd power. The cube cancels out the cube root, and I get 3y plus 1 equals, okay, negative 5 cubed is negative 125. Subtracting 1 from both sides, I get 3y equals negative 126. Divide both sides by 3, and I get y equals negative 42, I think it is. Let me do my calculator here quick. 126 divided by 3. Yeah, that's going to be negative 42. Okay, good. Okay, inequalities. These are all one answer. 38, 7/27, negative 42, 5. One answer. These, you're going to get more than one answer. Infinitely many answers. Like we're going to get x is less than or equal to something. I don't know what it is. You have to be careful with these because you can't take the square root of a negative number. So you have to check and see, make sure your answer isn't affected by what could possibly be the domain or not the domain. So we're going to check this in a minute here. Solve it the same way, okay? Actually, I'm going to do this first. We're going to do the check first. I'm going to say, hey, first of all, 4x minus 4 has to be greater than or equal to 0 because I can't take the square root of a negative number. So this just kind of keeps me honest. I'm going to add 4 to both sides, and I get 4x is greater than or equal to 4, divide by 4, and x is greater than or equal to 1. Now that's not technically my answer. That's just maybe could affect my answer. My answer is going to be when I solve this inequality right here. Same thing, isolate the radical, that square root, so I'm going to subtract 2 and get the square root of 4x minus 4 is less than or equal to 4. Okay, now I'm going to square both sides to get rid of that square root. That's what we want to do. We isolated the square root, now we get rid of it. So squaring a square root cancels it out, and I get 4x minus 4 is less than or equal to 4 squared is 16. Add 4. And I get 4x is less than or equal to 20. Dividing by 4. Here's my actual answer. X is less than or equal to 5. Unless it bumps into this. Well, my answer, graphing on the number line, let's say 5's there and 1's here. It's less than or equal to 5. And that's fine until I get to 1. It has to be greater than or equal to, if I have an answer, it has to be greater than or equal to 1. So basically it stops right here. It doesn't go any further than that. So my actual answer isn't just x is less than 5 or x is greater than or equal to 1. It's between 5 and 1. So I'd write my answer like this. 1 is less than or equal to x, which is the same thing as x, if you read it backwards, is greater than or equal to 1. And x is less than or equal to 5. That's how you'd write an and statement. So you got to see what your answer cannot be. It can't be anything. It's got to be greater than or equal to 1. If it's Less than or equal to 1, it would be negative, and that would make it undefined. So that's what we're working with there. Okay. Move that over, and let's look at this bad boy. First of all, I'll do it over here on the side. 2x plus 2 has to be greater than or equal to 0 because I can't have a negative number underneath there. That would make it undefined. So subtracting 2, I get 2x is greater than or equal to negative 2. Divide by 2. X is greater than or equal to negative 1. Okay, so as long as it's greater than negative 1, my answer's fine. But if it gets close to negative 1, well, then we gotta figure out what it's going to be. So we'd graph our answer and then basically what our domain would be. Domain values could or couldn't be on the number line. So subtracting 1 first of all. 2x plus 2, square root of that, is greater than or equal to 4. I'm going to square both sides. And the square cancels out the square root, and I get 2x plus 2 is greater than or equal to 16 again. Subtract 2, 2x is greater than or equal to 14, and divide by 2, I get x is greater than or equal to 7. Okay, so here's my answer, 7. It's greater than or equal to 7 going this way. My answer has to be greater than or equal to negative 1. Well, and it is. So this isn't technically part of my answer because my answer doesn't kick in until we get to 7, but it is greater than negative 1, so that's fine. So this right here, and that's usually what happens when it's a greater than problem. When it's less than, then it's going the other direction. Then you got to stop at that checkpoint or whatever you can't have underneath your square root. So yeah, it's greater than or equal to 7 here. So that worked out nicely. Okay, this is less than again, so I'm probably going to bump into, hey, 4x minus 4 has to be greater than or equal to 0. Because that can't be negative underneath the square root. That's what you would say. So 4x is greater than or equal to 4 because I added 4 to both sides. Divide by 4. X is greater than or equal to 1. Okay? Not necessarily my answer. I just can't have anything less than 1. It's got to be greater than or equal to 1. So isolate this. So we're going to add 2. And I get the square root of 4x minus 4 is less than 6. These cancel out. Okay, the square root is isolated, so I can go ahead and square both sides so I can actually solve this equation because I got to get my variable out of that radical. It cancels it out. The square cancels out the square root. And I get 4x minus 4 is less than, in this case, 36. Add 4. 4x is less than, what do we got, 40. Divide by 4. X is less than 10. Okay, but here's 10, here's 1. It can't go past this. It's got to be greater than or equal to 1. Now, this is just less than, so I'm just going to circle it and leave it open, but it's less than 10. So basically, it's between 1 and 10. How would I write my answer? Well, 1 is, I'm going to put x in the middle here, and just less than or equal to. 1 is less than or equal to x, which is the same as x is greater than. If you read it backwards, that's greater than or equal to 1. And x is less than 10. This would be my answer right here. Okay, that would be the same thing. I think we've done enough of these. Let's jump into this one. Ponderal index, P, is the measure of a person's body mass on body based on height in meters and mass in kilograms. One such formula is P equals, I'll write it right here, equals the cube root of M over H. A 70 kilogram, no, M is mass, and H is height. Okay, and then P is that ponderal index. Okay, what does it got here? A 70 kilogram person is 1.8 meters tall and has a ponderal index of 2.29. If you plugged them in, you'd get 2.29 for P right here. How much weight could such a person gain and still have an index of at most 2.4? Okay, so the P is going to be 2.4. The mass, well, we're going to add something to 70, so I'll say M plus 70 because he's already at 70, he or she. And the height, well, that's not going to change, that's 1.8. So now we got to solve this. I'm going to cube both sides, but I got to get this cube root by itself first. So I think I have to multiply both sides by 1.8. Multiply by 1.8, just multiplying that. Okay, let me do this quick. 1.8 times 2.4, and I get 4.32 equals the cube root. Now that's gone, of M plus 70. Already at 70, we're going to add some mass to it. I got to get rid of this cube root, so I got to cube both sides. Okay, 4.32 cubed is 80.62. And that's equal to M plus 70, because the cube cancels out the cube root, and that's all I'm left with is M plus 70. Subtracting 70 from both sides, that person could gain at most 10.62 kilograms. And there we go. That's kind of applying those cube roots and fourth roots, square roots to a real world problem. Go ahead and work on the